All right, let's do a little quick tutorial on how to find the equation of a tangent line. So let's look at a nice easy function, x squared plus 4. So that's just a nice quadratic. It looks something like that. Okay, so let's say we wanted to find the equation of the tangent line at x equals 1. I'm going to give you that value, x equals 1. So really what I'm doing here is I'm going over to 1, which is like 1 comma 5. And I want to find the equation of this line, the tangent line. The tangent line intersects the curve at that single point. Now what is that point? Well, if you know x is 1 and you know y equals x squared plus 4, then you do know that y is equal to 5. So we're talking about the point 1 comma 5. And to write an equation of that line, well, we need the slope. And the slope of the tangent line is the same as the slope as the function at that point. And again, how do we find slopes? Well, we have to take derivatives. And so then dy dx, the derivative of x squared plus 4 is just 2x. And so then another way to say that is y prime. So y prime of 1 is equal to 2. So now we have a point and we have a slope. Those are really the two qualities we need in order to write the equation of a tangent line. Writing the equation of a tangent line is writing the equation of any line at this point. You can go back to algebra 1. You can either use y equals mx plus b. Let's use that first. So we know we have a point that's 5, y value, slope of 2, x value of 1, and that finds us a b value of 3, which tells us our equation is a slope of 2, so 2x plus 3. And there's the equation of our tangent line. Or we can use point slope, it doesn't really matter. Y minus y1 equals m times x minus x1. y1 and x1 are our point, m is our slope, and so we'd say y minus 5 equals 2 times x minus 1. Y minus 5 equals 2x minus 2, add the 5 over and get y equals 2x plus 3. Both methods take about the same amount of time and really are doing the same thing. Okay, so we have the equation of our tangent line. This 2x plus 3 is the equation for the red. And again, the tangent line has the same slope as our curve at that point and just touches that point. And it, of course, does include that particular point. Well, what if you didn't want a tangent line? What if you wanted a normal line? Normal, which is the same thing as perpendicular, which is the same thing as orthogonal. All those things mean the same thing. What we'd be looking for in that case is this dotted line. We want it to be perpendicular to our curve. But the orthogonal line still has to include the point 5 comma 1, and then what slope does it have? Remember, a perpendicular line has to have an opposite reciprocal slope. So instead of a slope of 2, we want a slope of negative 1/2. So we end up doing the same thing. Let's go ahead and use point slope. So it's just y minus 5 equals negative 1/2 x minus 1. Y minus 5 equals negative 1/2 x, and that's going to be plus 1/2. And then we get y equals negative 1/2 x, 1/2 plus 5. Oh, what's that? Just 11/2 or 5.5, however you want to write it. And again, that's the equation of this dotted line. So finding normal lines and finding tangent lines are really the same procedure. You have to identify the point. Usually they just give you the x value and they give you the curve and they say write an equation of the tangent or normal line. But with the curve you can find the derivative. With the x value, you can find the y value, and with the x value, you can then establish the slope you need. Well, the derivative tells you the slope of the tangent line, so that's the slope you use. And if you want the normal line, well, then you just use the opposite reciprocal slope and get that. So most of the problems involve stuff like this. You might ask the question, well, why do we need to find equations of tangent lines? Well, probably the first two things you're going to do in calculus, or maybe the interesting ones, is you will eventually use tangent lines. And you will notice that there are two really nice tangent lines here. There's the tangent line here, and there's another cool tangent line right there. in that you'll see that when you have a horizontal tangent line, you typically have a maximum or a minimum. And finding maxes and mins is just a nice application of things. It's in the optimization section. It has tons of applications in engineering and physics and economics and business that we want to maximize or be the most efficient at doing something. Well, we want to be able to find these points, and these points do correspond typically to horizontal tangents where the slope is equal to 0. And the other thing we want to use tangent lines for is that tangent lines are really linear approximations or linear models. And so I'm going to just do one real quick one where I look at the sine curve. This will pop up in your AP Physics class. Then there's your sine function, and there is the tangent line at x equals to 0. And so you can have y equals sine x, and then the tangent line is just y equals x. But the tangent line is what they're eventually going to call the linear approximation, or the first order model, that if you look when x is really small, y equals x and y equals sine x are almost identical. So what we're saying is that sine x is approximately equal to x when x is small, and that means anywhere in the problem you see a sine x, you literally can just cross it out and you can put in an x. And so if you're interested in looking at more of this, I would suggest looking up the derivation of a pendulum. If you look at a pendulum oscillating back and forth, the period of the pendulum is going to make this substitution. Again, it's going to use a linear approximation or a tangent line approximation. Okay? But in general, finding equations of tangent lines and normal lines just require you to find a slope and a point, and then either use y equals mx plus b or point slope, and then to get your equation.